For as long as humans have gazed into the night sky, the moon has held a special place in our imagination. It is our constant companion, the brightest object above us, after the sun, shaping our tides, and even inspiring myths and poetry. Some cultures feared it weaving legends of werewolves, while others saw it as a symbol of romance. But beyond its cultural meaning, the moon has a very practical role in humanity's story. It is widely recognised as the first stepping stone in our journey to the wider solar system. Before we can dream of setting foot on Mars or building bases among the outer worlds, we must first learn how to live sustainably just 384,000 kilometres away on our closest neighbour. Yet, despite all its promise, the moon is not a friendly place. The last time humans walked on its surface was back in 1972 during Apollo 17. That mission was brief, and the challenges they faced were only the beginning. Today, as we prepare to return, we are realizing that the moon hides dangers far more subtle and far more threatening than we ever imagined. So let's explore together: what treasures does the moon hold? What unseen hazards lurk on its surface? And what solutions are being developed to overcome them? And perhaps most importantly, what does our return to the moon mean for the future of humanity? Over the last few decades, lunar programs have revealed something extraordinary. The moon is not just a barren wasteland. It is rich in resources that could one day support life and industry. Among these are rare earth metals helium-3, an isotope with the potential for future fusion energy, and most importantly, water ice. The first hints of lunar ice came in 1998 when NASA's Lunar Prospector Orbiter detected possible traces in craters near the poles. To confirm, scientists took a bold step. They deliberately crashed the spacecraft into one such crater, hoping to see a plume of vapor rise into space. A decade later, India's Chandrayaan-1 mission provided further confirmation, detecting water ice near the North Pole. Today, estimates suggest the moon holds as much as 600 billion kilograms of frozen water. That's enough to sustain human colonies for generations. But perhaps you're wondering, how could water survive here at all? After all, the surface of the moon in direct sunlight can reach 127 degrees Celsius, hot enough to boil water instantly. The answer lies in shadow. Because the moon's tilt is only about 5 degrees, there are craters near its poles that sunlight has never reached in billions of years. Within these permanently shadowed regions, temperatures plunge to minus 240 degrees Celsius, cold enough to preserve ice indefinitely. This ancient ice could be harvested to produce drinking water, oxygen for breathing, and even hydrogen and oxygen fuel for rockets. In other words, water makes the moon not just a destination, but a launch pad to the rest of the solar system. But as with every promise, there is a catch. Collecting this ice and living on the moon in general presents hazards unlike anything on Earth. First, the problem of electricity. Because of the moon's low tilt, solar wind particles sweep past the polar regions almost horizontally. Electrons, being far lighter than ions, cascade into the craters, faster, leaving behind a separation of charge. Over time, the interiors of these craters can build up voltages of hundreds of thousands of volts. Imagine stepping into one of these shadowed basins, an invisible electric field strong enough to damage equipment or worse, harm an astronaut. Then there is the notorious lunar dust, known as regolith. This is not soft sand. It is a fine, jagged powder created by billions of years of micrometeorite impacts. With no atmosphere or magnetic field to protect it, the moon's surface becomes charged by solar wind, causing the dust to cling to everything. During the Apollo missions, astronauts reported that the dust stuck to their suits, scratched visors, and even irritated their lungs when it was carried back inside the lunar module. They described its smell as similar to burnt gunpowder. What's more, When dust-coated spacesuits were made of woven Teflon, the material itself sometimes acted as a conduit, amplifying static charge. In lab experiments, Teflon covered in simulated regolith even produced electric sparks. So picture this: astronauts trudging across the moon dust, clinging to their suits, static building up around them, while above, solar wind streams overhead. The situation is not unlike rubbing your feet on a carpet and then touching a metal doorknob, except in this case, the shock could be lethal. This is why surviving on the moon is not just about bringing the right tools. It's about designing for an environment where dust is toxic, temperatures swing violently, and electricity itself could be your enemy. How can we overcome these challenges? The answer lies, as always, in human ingenuity. Future lunar spacesuits will need to do more than just insulate against temperature extremes. They must also dissipate dangerous electric charges, preventing arcing and shocks. Some researchers suggest rubber-like insulating materials, though these must withstand temperatures as low as -247 degrees Celsius. Others are experimenting with entirely new fabrics and composites. Then comes the dust problem. At Washington State University, scientists have tested liquid nitrogen sprays that can freeze and trap lunar dust, allowing it to be brushed away cleanly. NASA, meanwhile, is developing electrodynamic dust shields, special panels that generate electric pulses to repel dust from equipment and habitats. Perhaps the most futuristic idea comes from a Norwegian company, Intention. Their system, called ASG, uses human-machine interface technology to let astronauts control rovers, robotic arms or heavy machinery with simple hand movements. Imagine standing safely inside a lunar base, gesturing with your hand, and a robot outside obeys, digging, drilling, or transporting ice. This technology could reduce the risks astronauts face on the surface, while still allowing vital work to be done. Each of these solutions reflects a larger truth. The moon is forcing us to innovate in ways we never had to on Earth. And those innovations will not only help us survive on the moon, but may also prepare us for even harsher environments on Mars and beyond. So when might we actually see humans back on the moon? China, in collaboration with Russia, has announced plans for 3 major missions, Chang'e 6, 7 and 8, by 2029. Their goal to establish a robotic research station at the lunar South Pole by 2030. The United States has its own ambitious plan, the Artemis program. Artemis 1 has already launched as an uncrewed test flight. Artemis 2 will send astronauts into lunar orbit, and Artemis 3, planned for no earlier than 2025, aims to land humans on the moon for the first time since 1972. NASA's vision is to build a sustainable base at the South Pole by the end of this decade. Think about what that means. For over 50 years, the footprints left by Apollo astronauts have remained undisturbed in the lunar dust. Now, in our lifetime, new footprints may soon join them. The return to the moon is no longer a dream, it is a developing reality. Space will always be dangerous. The moon, despite its beauty, is no exception. Hidden electrical fields, toxic dust, and extreme temperatures all conspire against us. But humanity has a gift, the ability to recognize these dangers and invent solutions. By mastering the challenges of the moon, we are not just returning to a place we once visited. We are taking our first real step off Earth, learning how to build, adapt, and survive beyond our home planet. The moon is a proving ground, a training ground, and perhaps one day a launch pad to the rest of the solar system. And once we have conquered its silent surface, the wider cosmos awaits with all its mysteries, its planets, and its endless possibilities.